Welcome to Royal Chemistry Park, the YouTube channel. In this channel, we have seen previously the free radical reactions of part 1 and 2, in which we have seen the halogenation addition reactions, the generation and the stability of the free radicals. In this video, we are going to see the rearrangement reactions as well as the aromatic substitution reactions. I am Dr. K. Rajarajan, Associate Professor and the Head of the Department of Chemistry, Raja Sarfoji Government College, Thanjavur. Now let's get into the video. Free radical reactions, part 3. Aromatic substitutions. The aromatic compounds undergo substitution by some free radicals. The most common free radical is the aryl radical, which is generated from a number of compounds as illustrated below. For example, we can take benzene diazonium chloride. In reaction with OH minus, it will able to give rise to a phenyl free radical. Likewise, phenyl azo triphenyl methane gives rise to phenyl free radical also. Lead tetrabenzoate, this also gives rise to phenyl free radicals as shown in the screen. The aryl radicals are generated much more clearly if N-nitroso-acetylenides are used and they yield nitrogen quantitatively when decomposed in aromatic solvents as shown here. Here also you can have the phenyl free radical like this. Arylation of aromatic compounds by diazonium salts. When the abnormally acidic solution of diazonium salt is made alkaline, the aryl radical of the diazonium salt couples with another aromatic rings as follows. This is known as Gomberg-Bachmann reaction and has been used to convert benzene derivatives to substituted diphenyls. The phenyl radical attacks the substrate to give the intermediate from which a hydrogen is abstracted to give the final product. Here, the phenyl radical, when this attacks this substrate, it forms the intermediate in which the abstraction of proton is taking place. The reaction takes place in alkaline medium because in acidic medium the diazonium salts are ionic and when they cleave they give the aryl cation. So the reaction is polar. In alkaline medium they are converted to covalent compounds which cleave to give free radicals. With the phenyl azotriphenyl methane, the mechanism appears to be as follows. So the phenyl azotriphenyl methane gives rise to phenyl free radical and it attacks the substrate as such. Arylation by peroxides. The aryl radical generated from the peroxide attacks the substrate to give an intermediate as in the above example, but since there is no stable free radical to abstract a hydrogen atom, the intermediate either dimerizes or undergoes disproportionation. So if it dimerizes, it will do so as follows. So the dimerization reaction is shown here, whereas the disproportionation will give the following two products. Now let's talk about the free radical rearrangement. Decarbonylation of phenyl isovaler aldehyde giving a mixture of hydrocarbons in which 80% of the product is that coming from phenyl migration. Complete rearrangement occurs for polyphenylated compound. It is partial for singly phenylated radical as in the example of phenyl isoval aldehyde and there is no rearrangement for non-phenylated radicals. The fact that only phenyl groups undergo shifts in rearrangement suggested that the reaction goes via a bridged intermediate. Such aryl shifts involving 1,2 shifts will not occur unless there is considerable crowding in beta carbon atom. So far we have